This is R.D. Sharma solution, class 12, chapter 11. Differentiation we are taking. This is exercise 11.1. Differentiate the following functions from first principles e to the power minus x. So the first few questions are related to e raised to the power x only. But here the main the theory or the concept of this exercise is all about the first principle. How are we going to get the first principle differentiation? So if a function is fx, you want to have a differentiation using the first principle, that is d by dx of fx. Then what you are going to do is wherever x is there, you have to put x plus h so that it becomes fx plus h. And you have to subtract the original function from this, minus fx. And you have to divide it by an h. H is a very small number equivalent to 0 but not equal to 0. Limit h tends to 0. So the result will come, and that result will be the differentiation. So this question, we have e raised to the power minus x. So what is fx plus h first? Because fx is given as e raised to the power minus x. So just replace x by x plus h. In order to find out d by dx, use this relationship you can call, which has come from a previous discussion of differentiability. So x plus h I am taking, because fx plus h minus fx. What is fx? E raised to the power minus x. And this is what? And then we have divided by h. And then you say limit h tends to 0. Okay. Now how to solve this? This limit h tends to 0 and division by h, I will skip some time, but you have to understand on the left the answer I always give is because I want you to know how to write in the examination, because the whole marks is not only by solving but how you have solved it. That is how examination needs to know. So e raised to the power minus a plus b is e raised to the power minus a minus b. It can be written as e raised to the power minus a into e raised to the power minus b. Okay. So power gets added when you have the same base. For example, x raised to the power a multiplied by x raised to the power b is x raised to the power a plus b. Same thing we are going to do here. E raised to the power minus x into e raised to the power minus h. That's what we have used this. That's why I told you this. And e raised to the power minus x divided by h. Now this e raised to the power minus x you can take common. So in all these 5 questions which we are going to do, we'll take certain things common. So I've taken common. Now e raised to the power minus h is inside, minus 1 will remain, and now I will have this divided by h, which is already there. So in all differentiability continuity, we have used certain relationship which you are going to use in abundance. That is e raised to the power x minus 1 divided by x equals 1 when you have limit h tends to 0 or x tends to 0. So this is not h tends to 0, just consider it to be x tends to 0. Okay, limit x tends to 0, e raised power x minus 1 by x equals 1. So when you apply this limit h tends to 0, limit will be only applied where h is there. E raised to the power minus x you can take common, because x with respect to h is a constant. So this, you have a x and you have a x here. So you need to have a x in the denominator as well. So you have a minus h in the numerator, you have to have a negative h in the denominator. So now you can multiply this negative, because you have introduced a negative, so negative will come outside. Now from this to this, you will use this relationship e raised x minus 1 by x equals 1, limit h tends to 0. So only minus e raised to the power minus x will remain. And this is the differentiation. Okay. Now same thing here, e raised to the power 3x, differentiate the following functions from first principles, e raised to the power 3x. Now this chapter, this differentiation chapter is a huge chapter, big. Okay, so it will take a lot of time, so I will just try to save time by writing those aspects which only pertains to the logic. So limit h tends to 0, fx plus h minus fx by h, that we have to do. So e raised to the power 3x plus h is fx plus h minus e raised to the power 3x it is, divided by h. I am going to write it later. Limit h tends to 0 also I am going to use later. This limit h tends to 0, just consider it will always be there till it is applied. So on the left you can see how you have to solve it, and on right you have to understand how you have to solve it. Okay. Now here, so e raised to the power 3x plus 3h minus e raised to the power 3x. Now same thing, e raised to the power a plus b can be written as e raise a dot e raise b. So this can be e, this can be any variable, x, y or whatever. So e raised to the power 3x dot e raised to the power 3h minus 3 e raised to the power 3x. Just take 3 e raised to the power 3x common, you raise e raised to the power 3h minus 1, and then you have a h in the denominator. This can be there, and now e raised to the power 3x you can take always common because it is not related to h. And I told you e raised to the power x minus 1 by x, limit x tends to 0 is going to be 1. This is 3h, you need a 3h in the denominator. When you have a 3 introduced, you ought to have a cancellation of 3 in the numerator as well. This whole limit is going to be 1. And then what do you get? 3 into e raised to the power 3x. Right? This is your differentiation. D by dx of e to the power 3x is 3e to the power 3x. By using the first principle. Now e to the power ax plus b. So fx plus h minus fx divided by h, limit h tends to 0. So this it is now in your, it should be in your mind, this formula. E raised to the power ax plus h plus b minus e raised to the power ax plus b divided by h, and limit h tends to 0. I am skipping it for now. Let us concentrate on the numerator. So this is e raised to the power ax plus ah and then plus b. So ax plus b I am taking together, ah after that, and then I can write it as e raised to the power ax plus b multiplied by e raised to the power ah. Alright, this I am going to replace here. So e raised to the power ax plus b multiplied by e raised to the power ah minus e raised to the power ax plus b. So you can take common this e raised to the power ax plus b, and inside that you will get e raised to the power ah minus 1. Alright. Now limit h tends to 0. As I told you, this you have to write always. H was already there in the denominator. I was just not writing it. Now you know that limit h tends x tends to 0, e raised to the power x minus x is equal to 1. You have a ah here, you need to have a ah in the denominator also, so you can introduce a in the numerator and denominator. This whole, when you apply the limit, it becomes 1. So what is remaining? A into e raised to the power ax plus b. This is your final answer. So this is how you can solve it. I gave you the answer as well, because ultimately solution, the way it should be solved is all what gets you the complete marks in your examination. These questions which we are taking are mostly of e raised to the power. Those who wants to do themselves, the answer I always show just to have a reference for them, because they are different audiences I cater. So this you know already how to do this. Let me just give you for those who want to understand how to solve this question, because these questions have some tricks. E to the power cos x plus h minus e to the power cos x divided by h, limit h tends to 0 is our first principle. Fx plus h minus fx by h, limit h tends to 0 is our first principle. That's what I applied here. Alright. Now this numerator I am going to first solve, because this is the main thing in first principle, always the numerator. If you can solve it, if you can get something common out of it, cancellation is quite easy. So this cos A plus B, even if you open this cos A using cos A plus B, I have seen and I have tried, you won't get anything. That is, cos A plus B. Cos A plus B is proper expansion. So what we will do here is e to the power cos x, I am taking common from these two. So when you take common, this e to the power cos x plus h will be there, but e to the power cos x will come in the denominator because you have taken something common which was not there already with e to the power cos x plus h. But with this term, it was there. So it will be only 1. Let us solve this one. What do you get here? So this is basically of the type a raised to the power x by a raised to the power y. It becomes a raised to the power x, a raised to the power y goes up, it becomes minus y. So a raised to the power x minus y is the result. So e to the power cos x was already there. This becomes e to the power cos x plus h minus cos x, and this goes up. That is why it has become negative now. And the power gets added, so negative power gets added. Minus 1. Okay, now see, we have limit h tends to 0. Up till now we have seen e to the power, this limit x tends to 0, e raise x minus 1 by x is equal to 1. That's we have seen. So this e raise whatever is there, I am not speaking it, but whatever is there, just write that thing in the denominator. Cos x plus h minus cos x in the denominator. And that also should be in the numerator because you are introducing by yourself. So what we have done is the e raised to the power whatever is there, I introduced in the denominator. Why I did it? Because we know the formula. Limit h, when you apply this limit h tends to 0, then what do you get? This whole, this is a proper formula for that. So you can apply it here. Right? So when you just apply this, e to the power cos x will remain. This becomes 1, and now you have cos x plus h minus cos h. Alright? Now you have cos a minus cos b. Divided by h is already there, limit h tends to 0 is already there. And this is by default, okay? You have to keep in mind. Now this cos x plus h minus cos x, which is cos a minus cos b, and cos a minus cos b is simply minus 2 sine a plus b by 2 sine a minus b by 2. This formula you have to, by a previous classes, I just think that you know it. So I'm writing it minus 2. Then we have sine a plus b by 2. What is a? X plus h. What is b? X. So x plus h plus x, 2x plus h by 2. Then we have a sine x plus h minus x. X plus h minus x is going to give you only h. So you get a sine h by 2. Now this is good for us because we already have a h in the denominator. Write it here. Now since we have h by 2 in the numerator, you have to introduce a 2 here. So you have to have a 2 also here. Now apply the limit here. 2 sine h by 2, h by 2. I told you limit h tends to 0 is already there. So you have a limit h tends to 0 I am applying. Now you also know up till now limit h tends to 0 sine h by h or limit theta tends to 0 sine theta by theta equal to 1. So this 2 gets cancelled. Okay. Minus e raised to the power cos x was already there, which was taken earlier common. So you have taken minus also. This becomes 1. Now sine 2x plus h by 2. Apply h tends to 0 here. Limit h tends to 0. So when h becomes 0, it will be sine 2x by 2. 2 gets cancelled. You get only sine x. So you have a sine x here. And then e to the power cos x here. And a negative here. Okay. So the final term is your answer. Okay. So this I have skipped limit h tends to 0 sometime, division by h also skipped sometimes, but when I actually required it, I introduced it. Logic I told you, and this type of question should be solved like this. Again, e raised to the power under root 2x. So same criteria or the process of solving the e raised power should be adopted. Limit h tends to 0, you have to always write. Division by h, always you have to write, because we are using fx plus h minus fx by h. Limit h tends to 0. This is our solution of differentiation by the first principle. So e raised to the power under root 2x plus h minus e raised to the power 2x and divided by, I am saying limit h tends to 0 is already there, divided division by h is also there. Keep these things in mind. Alright? Okay. So what can we do? Here there is nothing to be, we can do nothing now. So the only thing which is remaining, what we have done in the previous question, is take e raised to the power under root 2x outside. So e raised under root 2x outside you have to take. So this term I am talking about. So e raised under root 2x you are taking common, and that term has to be in the denominator of the first term because you have forcefully taken it out. So e raised under root 2x plus h divided by e raised under root 2x minus 1, and then you have divided by, this divided by h I am not writing right now, limit h tends to 0 also I am not writing. But I just told you that e raised a, e raised b in the denominator, e raised a dot e raised minus b, it will be e raised a minus b finally. This will be e raised under root 2x plus h, and this is not 2x plus h, it is 2 into x plus h. Okay, e raised 2x plus h minus, this minus is after under root 2x plus h. So this minus under root 2x it will be, and then you subtract it. So this subtraction is from under root 2x plus h. Now this term minus 1, okay, now this whole term, you know that e raised to the power x minus 1 by x, limit x tends to 0 is going to be 1. So this whole term I want in the denominator. So I will just introduce this term in the denominator, or add this term in the denominator, 2 into x plus h minus under root x, and this should also be in the numerator. So under root 2x plus h minus under root 2x. Same thing, same term which is in the raised power of e, you need to have it here also. So same thing. Now this gets cancelled, so there is only the introduction. We just introduce it because we want that relationship when we apply the limit h tends to 0 to be 1. So this is a, you can call it also as a or some x. So if you take e raised a minus 1 by a, limit a tends to 0, it's going to be 1. So this, when you apply the limit, this whole term is going to be 1. Okay, I'm eliminating this term. This is 1 now. Only thing remaining is under root 2x plus h minus under root 2x. What was outside? It was already e raised under root 2x was already there. Division by h is already there. Limit h tends to 0 was already there. Now this term is simple term to rationalize. So same term with a positive sign in between, just multiply this, numerator denominator. Under root 2x plus h plus under root 2x in the numerator and denominator. Alright. So this is, and you know that a minus b, a plus b, when you multiply them, you get a square minus b square. A minus b into a plus b is what? A squared minus b squared. This square, so it is under root. So when you take the square of the under root, the square root vanishes. So you only get 2 into x plus h minus 2x in the numerator. 2x plus 2h minus 2x, 2x gets cancelled. You have a 2h here, and we are very fortunate that h is already there in the denominator. So you can just cancel these out. E raised under root 2x was also there. You can cancel this out. So 2 into e raised to the power under root 2x is already there. Now only denominator is remaining. So let us apply a limit h tends to 0 here in the denominator. So wherever h is there, make it as 0. So you have under root 2x plus under root 2x in the denominator. This under root 2x plus under root 2x becomes twice of under root 2x. So this is twice of under root 2x, and you see that 2 is already there in the numerator. 2 into under root 2x is the what you got from the denominator, and I told you 2 into e raised under root 2x was there under, and 2 into under root 2x in the denominator, 2 gets cancelled. E raised under root 2x by under root 2x is your final answer. That is your answer by first principle. On the left, step by step, how you have to do in your examination, how you have to write in your text or copy, that you have to do. The understanding of the logic I gave you on the right. And you have to write everything like the rationalizing the numerator. So what I am speaking, you have to write. Differentiate the following functions from first principles, log cos x. Now the first principle we already know. It is fx plus h. If this function is fx, then fx plus h, wherever x is there, we'll put x plus h. Minus fx divided by h, limit h tends to 0. So this what we do in first principle. So those who want to do themselves, I have given a reference, and those who want to understand, just see the logic, how do we go about it. We have log cos x plus h, because x plus h we have to do, minus fx, that is log cos x, divided by h, and limit h tends to 0. So these two we are going to use wherever it is required. Let us see the numerator first. And in log, we know the property log a minus log b is nothing but log a divided by b. You can also call it as log x minus log y is equal to log x by y. So let us write it as log cos x plus h divided by cos x. So are we going to get something out of it? Not yet. But we have certain relationships, certain identities that we have been using, and that will be used all through your differentiation and integration. Log 1 plus x divided by x, limit x tends to 0 is equal to 1. And we have e to the power x minus 1 by x, limit x tends to 0 equals 1. So this need to be kept into your mind. But we don't have any 1 plus here. So we will by ourselves add a 1, subtract a 1 in order to get this kind of identity. So 1, just keep it aside like this, log 1. And the other part, which is cos x plus h by cos x minus 1. Let us solve it in a different place. So this is cos x plus h minus cos x divided by cos x, that is cos x plus h by cos x minus 1 is cos x plus h minus cos x divided by cos x it will be. Alright. So now this whole you can keep it here. Now writing this will take some time. So I just use a symbol y in place of all this content. So log 1 plus y. But still you need a x in the denominator, that is whatever is y, you need a y in the denominator. So if you are including or introducing a y in the denominator, you also have to have a y in the numerator, because you are introducing by yourself. Now log 1 plus y by y, when y tends to 0, you don't have to do like this. You have to write everything by yourself, okay? You cannot just regard something like this. We will be doing it in a later question. But here, because this is not that big or that time consuming, so log 1 plus y by y is the whole term which on the right I have written. But log 1 plus y by y, log of this is going to be 1, which I already told you. So all of it, all this part, you can just call it as 1. So this whole which I am making making a boundary, the inside content will be 1. Now only y will be remaining. Y is what I regarded or used the symbol y for this whole content. So let us write it and try to solve it. So we have cos a minus cos b. Cos a minus cos b is minus 2 sine a plus b by 2 sine a minus b by 2. Let me write it here. Cos a minus cos b is minus 2 sine a plus b by 2 sine a minus b by 2. So this you can use. A is x plus h and b is x here. 2 sine 2x plus h by 2, and then we have sine x plus h minus x by 2. X gets cancelled, you have h by 2. Remember, h was already there in the denominator, so I'll use it here. Let us write this h in the denominator. But still, you know that sine theta by theta, so you need a theta in the denominator. So h by 2 has to be there. So 2 multiplied by h by 2. Now apply the limit in this circled area. It will be 1. Sine theta by theta, limit theta tends to 0 equals 1. 2 gets cancelled. You have minus 2 sine 2x plus h by 2. You can again apply the limit because you will not get any indescribable value. So minus 2 sine, this h is 0, 2 gets cancelled. So you have limit h tends to 0, 2x, this is 2 gets cancelled, you have x here. Alright, this is your sine x. So you have a sine x here, and if you remember, we have a cos x in the denominator also. This cos x was in the denominator. So right now, this is the time to have this cos x in the denominator. Minus sin x by cos x. Sin x by cos x is tan x. So this is tan x. Final answer, final solution of log cos x differentiation is negative tan x. Alright. So, I just wanted to show you how to do this. That's why I skipped something. Next is e root cot x. We have to solve it using the first principle. So those who want to themselves try this question, and they have a reference on the left I have given. But those who want to understand how this has to be done, we will be using certain identities. E raise x minus 1 by x limit x tends to 0 is equal to 1. This is the first thing. We will try to make this e under root cot x like this. The second relationship we are going to use is cot a minus b is equal to cot a minus cot b plus 1 divided by cot b minus a. Please remember, the b is first, a is later. Then we will use 10x by x or x by 10x. Both ways, when you take limit x tends to 0, we'll take limit h tends to 0, and this is equal to 1. There are certain other thing like cosec square theta is equal to 1 plus cot square theta. That also we are going to use. This I told you upfront because we will be applying it in the course of solving this question or differentiating using the first principle. Fx plus h minus fx by h, limit h tends to 0. That is how we go forward for the first principle. This is our fx. E raised to under root cot x is our first principle. Alright. So e root cot x plus h, that is fx plus h, minus e root cot x, this is fx, divided by h, limit h tends to 0. So whenever we have this h and limit h tends to 0, I am going to apply it, use it. But right now we are concentrating on the numerator. Numerator is very important. This, because we are not able to find any way out, the best way out is to take the e root cot x common. When we take e root cot x common, it was not there in the first term, so you have to divide that term so that when you multiply it gets cancelled out. So e root cot x plus h divided by e under root cot x minus, we already taken e that content outside, so you can have just minus 1. So what I am trying to suggest here is e under root cot x is the first term which is already we got. So I am just making it a circle around it in order for you to later know that we have this term already. There is one more relationship, x to the power a by x to the power b is x to the power a into x to the power minus b, and then you can add them, so it will be x to the power a minus b. This is same thing we are going to use, because base can be same, the power gets subtracted when you have in the ratio. E raise under root cot x plus h minus under root cot x, this is what you get here, minus 1 divided by e under root cot x. But see, e under root cot x is also there. So we need this term. We need this term under root cot x plus h minus under root cot x. So this term we require it. Okay. So what we will do here is this under root cot x plus h minus under root cot x that we have introduced. Okay. So this limit h tends to 0. And this whole term, because e to the power x minus 1 by x is going to be 1. Remember, this was already there. We are going to use it in a short while. This term, under root cot x plus h, this we are going to rationalize. So we have this term remaining, cot x plus h minus under root cot x. In order to rationalize, just multiply the same term with a positive sign. The same term with a positive sign, multiply here, under root cot x plus h. Then we have this under root cot x, same thing in the denominator. Under root cot x plus h plus under root cot x. So now we have a minus b, a plus b kind of situation in the numerator. This is a minus b, this is a plus b. A minus b and a plus b is a squared minus b squared. Since we have this in root, so you can get this value without the root, that is, root will be eliminated. So cot x plus h minus cot x divided by this term. Since this term is not giving us any untoward value, you can apply the limit h tends to 0 here only. So in the denominator, I am applying limit h tends to 0. It is going to be under root cot x plus h, h will be 0. So you have under root cot x plus under root cot x, that is twice of under root cot x. So twice of under root cot x we got. Now I am again circling it because this is the second term which we will be having in our answer. So what is remaining? E under root, this thing, let me write it here. E root under root cot x, twice of under root cot x is already there. Now we have to deal with this one, cot x plus h minus cot x. Now what is cot a minus b? Cot a into cot b plus 1 divided by cot b minus cot a. So if I just change the term, okay, replace the term, we have to, if I want to get a cot x minus cot x plus h, I have to multiply it by a negative. So when we multiply it by negative, it will be equal to the first term. So minus I will be using it. So I am just keeping this negative here. Cot x minus cot x plus h. So we will apply this formula. Cot b minus cot a will be equal to cot a cot b plus 1 divided by cot a minus b. So it will be cot x plus h minus x in the denominator. So we have cot a, cot b, cot x plus h plus 1 divided by cot x plus h minus x. X plus h minus x is what? X gets cancelled. You get a cot h. You have a cot h here. So now, see, you can apply again the limit here. So you get this h. Cot h is tan h. I told you tan x by x or x by tan x, limit x tends to 0, it is going to be 1. So this is going to be 1. So this whole term in the denominator is 1. So the term in the numerator is cot x into cot x plus h plus 1. Apply the limit here. Cot x, this is going to be 0. Cot x into cot x is cot square x plus 1. So cot square x plus 1, you know that cosec square theta, it is So cosec square x. Now this is what we got finally. Already we had this term. So I'm just taking this cosec square x here, and that will be our final value. That is going to be final answer differentiation of this term. Differentiate the following functions from the first principles. X square e raised to the power x. Same thing we have to do. If you want a reference, I have given you a reference on the left, and those who want to understand how it is being done, then this is the fx. This is actual function we have to differentiate, and when we differentiate we have to use this fx plus h. So I am adding h with the x and writing the function which is called as fx plus h, and then subtracting the original function which is our fx function, and it is nothing but x square e raised to the power x. It is not minus x, I'll just change it. Division by h and limit h tends to 0. Now these two things will be used. Okay, this limit h tends to 0 and division by h I am going to use wherever it is required. But whenever you are writing, you have to write this limit h tends to 0 and divide by h every step, in every step. So now let us open x plus h whole square, a square plus b square plus 2ab, x square plus h square plus 2xh. Multiply it with e to the power x plus h. So this is how it will be formed. Then we have this minus x square e raised power x. Now let us take this x square term together. When we take x square, so e raised x plus h, and then we have minus e raised to the power x. Then we have this h square e raised power x plus h, h square into e raised power x plus h. Then we have this 2xh e raised to the power again x plus h. So these there is no commonality here. So let us see this one. Now this is what we have solved earlier also, e raised to the power. So whatever we do is we will take the second term common. So when you take this e raised x common, so it will be e raised x plus h divided by e raised x and minus 1. Okay, so now this one, we have a relationship, and that relationship we have used when we were solving the e raised to the power x questions, and the equation or the identity is e raised to the power h minus 1 by h is equal to 1 when limit h tends to 0. Okay, so this x square we have taken common, e raised to the power x we are taking common from here. When we take e raised to the power x common, this e raised power x plus h divided by e to the power x, this goes up. So e raised x plus h minus x. So e raised h minus 1, and then we have x square e raised h minus 1. And please remember there was a h in the denominator already. So I am taking h for every term. The first thing which we will do is divide by h and multiply by h. That's what we do normally. But still because we have a h in the denominator already, so what we do, e raised h minus 1 by h, this is already there, so we don't have to multiply by h, and limit h tends to 0 is going to be applied, and this whole term which is in the circle or which is in the boundary is going to be 1. So this becomes 1. So what is remaining is x square into e to the power x for the first term. Second term h, just cancel it out, h into e to the power x plus h it will be. And the third term hh you can cancel, 2x into e raised x plus h it will be. So just apply the limit in these two terms and make the h as 0. So when you take this one, this is going to be 0 and h is 0 here, so only e to the power x will remain, 2x into e to the power x. So only remaining is these two terms, middle term becomes 0. So this is e to the power x, I am taking e to the power x common, it is going to be x square plus 2x. That is your final answer, final solution. Differentiate the following functions from first principles, log cosec x. And if you remember, we have already done a question in this exercise which was log cos x. So this question, the way of solving or the steps we are going to take will be same. log cos x. For those who want to do themselves, I have given a reference on the left. But those who wants to understand, let us understand it by fx plus h minus fx by h. Limit h tends to 0. This is what we have to apply. So log cosec x plus h minus log cosec x. So log cosec x plus h minus log cosec x and divided by h. That is the first principle when we have limit h tends to 0. I hope you will be able to write this, and this division by h and limit h tends to 0, as I was telling earlier also, we will be using it wherever it is wanted, but you have to use it, write it everywhere. You know that log x minus log y is nothing but log x by y. This is the property of log. So we have log cosec x plus h. You can write it in the numerator and cosec x in the denominator. So log a minus log b. So I am just writing the numerator now and I am trying to solve this. Then we will use this division by h and limit h tends to 0. So now this cosec can be converted into sine, because sine and cos is better to deal rather than going for cosec or sec. So we have cosec theta is 1 by sine theta. So this will be inverted with a sine. So sine x in the numerator and sine x plus h in the denominator. Okay. Now let us, what can we do? We cannot do anything right now. So the best way is to apply the known identity log 1 plus x divided by x when x is tending to 0 is equal to 1. So log 1 plus x divided by x, when we apply limit x tends to 0, it is going to be 1. So you can add a 1 and subtract 1 by yourself. So we have to do it by ourselves. Okay. So this sine x, this 1 plus whatever is there is your x and division by x. So 1 plus whole of it, which I'm circling right now, is what we have to divide also. So log 1 plus, let us solve it now, sine x minus sine x plus h divided by sine x plus h. So sine x, this is whole, you can say whatever is after 1 plus, that has to be, if you just say it is theta, log 1 plus theta by theta, theta tends to 0. So this is whole theta, you can say. Now we need this theta in the denominator also, because this is log 1 plus theta by theta. That is going to be 1. So you just call it as, say, theta. I am writing, assume that this is theta. I am writing theta in the denominator. Just assume that this is theta, that whole term after 1 plus. So we have to have a theta in the numerator also, that is the whole term. Now this whole term, this total 1 plus, I am calling this sin x minus sin x plus h by sin x plus h as theta. So when theta tends to 0 or h tends to 0, log 1 plus this term divided by that term is going to be 1. So only this theta, that this term will remain. Okay, we have applied log 1 plus theta by theta. So only theta will remain. I hope you got the idea. So we have introduced a term. So only this term, this theta, which is actually sin x minus sin x plus h divided by sin x plus h, that is going to be solved. And for that you have to know the value of sin a minus sin b. Sin a minus sin b is nothing but 2 cos a plus b by 2 sin a minus by 2. So these things you have to learn. If you don't learn, you can just learn by heart. Well, there are tricks to remember these. But right now, I hope that you know that sin a minus sin b is what? So 2 cos x plus h by 2, 2x plus h by 2. Then we have sin a minus b. That is x minus h. So you have sin minus h remaining. Okay, sin minus h by 2, because it is a minus b by 2. So you have sin minus theta is minus sin theta. You know already that. So I am taking this negative outside and I am just writing sin h by 2. Sin minus theta is minus sin theta, that is why minus I have taken in the front, and sin h by 2. Now this term you can just apply, see, wherever when you put h as 0, there is no undescribable or indeterminate term, you can always apply h as 0. Now we have a denominator also, we will be talking about that in a short while. So minus 2 cos 2x plus h by 2, and then, so we can safely apply h as 0 here. So you can apply it h tends to 0 here. Here also sin x plus h. Here also, if you apply sin h tends to 0, so sin x will remain. So there is no problem. But here we have sin h by 2. And please remember, I told you in the beginning there was a h in the denominator because first principle has a h in the denominator. So just divide by 2 and multiply by 2 because we want a h by 2 in the denominator also. Sin theta by theta, limit theta tends to 0 is going to be 1. That you already know. So sin h by 2 is going to be 1. I am applying limit theta tends to 0 here. H tends to 0 for example. In this case, 2 gets cancelled. You just have a negative. Now I am applying the h tends to 0 for cos 2x plus h by 2 and sin x plus h. So apply the limit here. H is going to be 0. 2x by 2 is 2 gets cancelled. You have a cos x. This goes 0. You have a sin x. So you have a minus cos x by sin x, that is going to be negative cot x. So this negative cot x is your final answer. Okay. Differentiate the following functions from first principles. Sine inverse. So sine inverse type of question we are doing for the first time. So how we are going to do this? Cos inverse theta or sine inverse theta. So this I'll tell you, but if you are willing to solve by yourself, then on the left I have given you reference and you can solve it by yourself. You can check whether you are going correct or not. But those who want to understand how it is being done, so don't worry about anything here. Just there are certain trigonometric relationship that you need to remember, because if you don't know those relationship, you won't be able to solve it. For example, cos a minus cos b, sin a minus sin b, sin inverse x minus sin inverse y, cos inverse x minus cos inverse y. All these needs to be understood. So you have sin inverse 2x plus h. I am applying the first principle. Wherever x is there, x plus h you make and then subtract it with the original function, which is sin inverse 2x plus 3. So sin fx plus h minus fx divided by h I am doing limit h tends to 0. Limit h tends to 0 and division by h I will be taking wherever it is required. I am not going to write it. So these two I am telling. We will be concentrating on the numerator. Don't leave this. Okay, you have to write this in every step whenever you are solving in the exam or in your classwork. Now sin inverse a minus sin inverse b or sin inverse x minus sin inverse y, that it has a relationship which I am going to tell you that you have to apply here. Without this you won't be able to solve it. Sin inverse x minus sin inverse y is sin inverse x into under root 1 minus y square minus y into 1 minus x square. Okay. So this sin inverse minus sin inverse x minus sin inverse y, this is a relationship you have to follow, and that the x is 2 into x plus h plus 3, y is 2x plus 3. H and limit h tends to 0 I will be taking wherever it is required. So let us take this first term. So we have 2x plus 2h plus 3. And this is the first term. And then we have the second term. Second term was 2x plus 3. So 1 minus 2x plus 3 whole square. Then we have minus y. Y is what? 2x. This y is 2x plus 3. So you write 2x plus 3. And then we have under root 1 minus x is 2x plus 2h plus 3 whole square. So there will be a point where only algebra is required. I am going to leave it for you. Okay? Please remember, because this will take a lot of time. Just understand the steps, the logic. So this is all inside sin inverse. I have not written it up till now just because I want to show that what is going to be inside. The inside one will be all this x into under root 1 minus y square minus y into under root 1 minus x square. So now we have sin inverse. Whatever you call it, say sin inverse, whatever is inside, I am calling it as theta. So sin inverse theta by theta is going to be equal to 1. Same as sin theta by theta is equal to 1 when theta tends to 0. So this whole term, if we are going to write it again and again, there is always a possibility in your exam also, because you have limited time, just call it as some z. So this sin inverse, I'm taking everything inside sin inverse and calling it as z. So it is going to be sin inverse z. So if I reduce a z in the denominator, I have to have a z in the numerator also. So whole term, please remember, the z is total term, this whole term which I am saying. So if you have to apply sin inverse theta by theta, then you have to have a z in the denominator and z in the numerator also. So this whole term sin inverse z by z is going to be 1 when you apply limit h tends to 0 in this term. So only z is remaining. That is, whatever is inside sin inverse, that is only left with you to solve. You got the idea? The value or the whole expression, I call it as z. That is the only thing we need to solve, because we know sin inverse z by z is going to be 1 and we have applied it. So we have an under root here. So either you open it, or the best thing is to rationalize it. If you want to get rid of the under root, the best way is to do the rationalization. So just call it as, say, this a and b I am saying. A is the first term, b is the second term. So a minus b, the rationalization is you have to multiply the a plus b and a plus b numerator denominator. So the numerator will get to you a square minus b square, and denominator will give you a plus b. So this whole term I am squaring it. 2x plus 2h plus 3 whole square, and the root of this will be a goner. So it will be 1 minus 2x plus 3 whole square. And then you have a subtraction and b square. So 2x plus 3 whole square, and then under root will vanish. So this is going to be only 1 minus, let me write it again, 1 minus 2x plus 2h plus 3 whole square. Now you will be tempted to put h as 0 here and try to solve it so that you get subcertain out of it. A plus b is in the denominator, which I am going to take just now, later. I am just taking the numerator first of all. Okay. So this whole term is nothing but a square minus b square, which I have already written. A plus b, which is the term which I regarded as a or symbolized as a and b, that is going to be in the denominator. But the numerator, I want you to solve it. I hope you will be able to solve, because if you put h as 0, see, I'm just trying to tell you that it is not solvable if you just put h as 0 here and you say, okay, I'm going to solve it. No. If you put h as 0 and you get some untoward situation, then you have to solve it. You have to open all this 2x plus 2h plus 3 whole square. You have to open it, a plus b plus c whole square. You have to know the formula. I'm just putting h as 0 and you will see what will happen. If you put h as 0, 1 minus 2x plus 3 whole square, and minus, again this is 2x plus 3 whole square. Now put h as 0 here. So 1 minus 2x plus 3 whole square. So if you put h as 0 in the numerator, without even solving it, you will get a 0 in the numerator. That is not what we want. Okay. So what I am trying to suggest here is that whole term which I have written, you have to solve it. Okay. So it may take some time for me. That is why I am writing the final solution of this expression of the numerator only. Denominator is a plus b. So see, this denominator will be a plus b. A is what? 2x plus, this is going to be 2x plus 2h plus 3, and under root 1 minus 2x plus, this is what I am writing, but this is not correct. This is incorrect. I am saying a plus b. I am writing a square plus b square. A square plus b square won't work. So that is a correction here. I'll just write a plus b. Don't worry. The only thing is this whole term a square minus b square. A I have taken. You know what I have taken. B, you know what I have taken. You have to take a square minus b square. You have to open everything. Okay, this is just algebra. I hope you will be able to do this, and you have to use that h. Once you open it all, then you have to apply h tends to 0. But you don't have to apply it up till now, because the final result will be 4h into h plus 2x plus 3. You need to verify it. Okay, I'm not doing it. I'm just leaving it to you. So you have in the denominator h also. I told you whenever it is required, I'll use it. And whatever is a plus b, I'm writing just as y right now, because we'll be using it. So first let us cancel this h and put h as 0 in the numerator. So you get 2x plus 3. Now in the denominator, I told you y. Okay. Now y is what? A plus b. Simply you have to write this first term a and second term as b. So what this is incorrect. This is incorrect. So a plus b, let me write it. A plus b is what? It is not square. Okay, a plus is simply first term and second term, you add it and put h as 0. Just put h as 0, because when you add them, it is not going to give you 0. So 2x plus 3 will get cancelled. There will be 2 in the numerator, and in the denominator you have 1 minus 2x plus 3 whole square. You can leave it here only. Please remember this term which I have written in the round bracket or showed, you have to solve it by yourself. That is going to give you 4h into h plus 2x plus 3. Then you have to put h as 0 after cancelling this first h from the denominator. 4 into h you have to cancel in the denominator, then only you will get the proper value. Okay, this is all about this exercise. Thank you so much. Take care of yourself.